So before I start off with PV diagram, I would want to discuss something very fundamental to graphs. Say I have a graph and you have your U versus A graph. And you have a line like this, for example. That's your graph. Now, what I'm trying to do over here is make you guys recall the phrase area under the graph. That's what I'm trying to do. So let's talk about area under the graph. So in terms of graph, in actual graph, area under the graph between point 1 and point 2 is what? It's basically literally the area under the graph. This region is area under the graph. Now, in terms of area under the graph, in terms of formula, what does it mean? It's basically nothing but your length, in this case, say A1 and A2, A2 minus A1, times of your height, say in this case U or U1. U1 minus U0. Say this is U0. That's the area under the graph. Graphically, it looks like this. In terms of formula, it would look like this. So this is in terms of graph. Graphically, it's so. And in terms of formula, this is so. Right? Do you guys agree? So with this understanding, we can start off with the PV diagram. So please see to that you understand this and recall this. Then we have our PV diagram. So till now, we have talked about energy in terms of heat and work. But it has been a bit or not so very clear. It's a bit ambiguous, right? So the next question is, how do we actually see a thermodynamic process happening? How do we understand it? Of course, the answer is graphs. So in this case, we have our PV diagram. Our PV diagram gives us a simple visual way to represent what a system is going through, right? What is happening with the pressure and volume for a given value of, say, volume, if not pressure. So that's one of the things. And another important thing about this is a PV diagram, it helps us calculate the work done by the gas. End of it, again, we have to go back to talking about work, energy. We have to talk about how much fuel is going in and how much is our output. Right? End of it, it's all about that. So to have such a conversation, we make use of PV diagram. Again, similar to this, right? Any graph, all of this works. You have your PV diagram. So in this case, in place of your y-axis, you have your pressure along this axis, and here it's volume. And in our case, the graph over there looked something like this, but I'm taking this. So here we have the projection. Okay, yes, this is not part of the graph. This is just the projection along your x and y axis and stuff. So that's along your x axis actually. So when I tell area under the graph, this is the area under the graph. Right? In terms of formula, area under the graph over here, area under the graph in a PV diagram will be what? Obviously, it will be V1 minus V2 or V2 minus V1 actually. V2 minus V1, that is nothing but a change in volume. And when it comes to pressure, it is P1 minus P2. Or sorry, P2 minus P1. So basically, we are looking at change in volume times of change in pressure. And this is nothing but your work. So area under the graph in a PV diagram gives us work. Okay, so this is your background. Let's see what I have written through. what we have done over here. What is the text basically? Okay. The aim of PV diagram and work done by a gas in thermodynamic process to understand work as area under the curve. So it makes understanding work a lot simpler because area under the curve is very simple to look at. So you will understand this when we are dealing with some engines and stuff. So you'll use this very thing to understand that. And if you understand this, then understanding the actual engine per se will be a lot simpler. Definition of a PV diagram. A PV diagram is a graph of pressure along the vertical axis and volume along the horizontal axis. So basically each point on the graph is a specific state of the system, right? So this, let me go to this graph. If I take up this point, this has a particular pressure and volume. This has a different pressure and volume. So it talks about particular state. And if I take up any other point in between, anywhere, every point has a different set of value. Either the X or the Y or both are changing. So in this case, pressure and volume. Each curve, a process, how it happens. So each curve represents a different process. So this process is different. And if I happen to draw a line from here till here, starting from A, but going towards B, even though the starting and the ending point are the same, they represent different processes. Why PV diagram matters? They make thermodynamic process visible. They let us compute work graphically. They show the difference between expansion, compression, and the cycles. So this is something that we will deal in detail in future, that is. So recall what is expansion and compression. When it comes to expansion, we are looking at volume increasing, gas pushing the piston, gas does positive work. When it comes to compression, volume of course decreases, work is done on the gas and work is negative. Again, this is to do with your delta U. So delta U, remember, has negative W. So if W has a negative, say 10 value, so negative of negative becomes positive, telling that the system gains energy because of the work, right? So that's why don't get confused. It goes back to this formula and the sign convention. So don't get confused over here. Y is negative when we are compressing the gas. Now we are doing work to the system, right? So this tells that work is done to the system. So why is the work negative over here? Because the formula is so. The formula will make it positive again. That's why we take it as negative. Okay, simple introduction, but that very idea of how we can talk about work in a PV diagram is important. Okay, so that's the whole idea, but it was just a 30-second video supposed to be that. But of course, going in detail helps us connect things easily in the future.